Okay, so here's our last video for this lesson. Newton's third law, in short, is called action and reaction pairs. For every action, here's action 1 for the actual definition. For every action, there's an equal and opposite reaction. So this is a good video to watch, Mythbusters. Kind of shows that action-reaction force. When it comes down to it, though, it's pretty straightforward. So you push the wall with a force of 220 newtons, the wall pushes back with what force? And again, this is assuming that the wall doesn't break. If we push that wall with 220, and I say nothing's moving, so that means the forces must be balanced. That wall must be pushing back with 220 newtons. You have a mass of 65 kilograms while standing on a surface. The surface pushes back with your what force? So we have an object has a force of gravity, and we've already kind of seen these things in action. Force of gravity. We know there's that normal force. That's the surface pushing back on us. Because again, there's a net force of 0. We know that the normal force must equal the force of gravity. So we solve our force of gravity, which is so F equals ma. But when we talk about force of gravity, a is just the very specific acceleration of 9.81 meters per second squared. So 65 multiplied by 9.81, we get 640 newtons. So force of gravity is 640 newtons. It must be pushing back on us with that 640 newtons as well. So it's asking us what's happening when we walk. So every step we take when we walk, so let's imagine here we are, we're walking on the earth. To walk, you push on the earth, but what's actually happening is the earth's pushing back. So the reason you move forward is because the earth pushed back on you. So technically what you're doing, every step you take, you're actually accelerating the earth in the opposite direction. However, it's not visible though, it's because the earth is so massive. If we take our equation, F equals ma, if we solve for a is equal to F over m. For yourself, you say, okay, acceleration is F over m. Because we are so small, in the grand scheme of things, we actually get a value for accelerations. We get a value. But for the Earth, though, acceleration of the Earth, for every step you take, that mass is so big. And if you ever divide by a huge number, it essentially equals to 0. So even though, yes, we are kind of propelling the Earth in the opposite direction, rotating around, the Earth already has so much momentum, rotational momentum, it's not going to be affected by a single step or even a billion steps that you take.